Hello, everyone. Today we are going to be talking about Marxist economics, about a topic in Marxist economics. It's a cautionary tale about assumptions and how they can lead to unexpected conclusions if not given a very careful treatment. It's also about the profit rate, which is one of the most important relations found in Marxist economics. So, a few years back, I made an illustrated pamphlet overview about this very topic. And while I am happy with it, some people would approach it and they would see all of the pages, the text, the formulas, and despite the graphics, they would say, nope, this is not for me. This is way too much, not doing this, which I find very unfortunate, right? So I'm actually making this in part due to accessibility, the video presentation format being one of the more accessible options. And I find that modern Marxist economics is very lacking in this regard, sadly. You would be hard pressed to go on YouTube and to find creators that actually make content which is suitable for someone who has a more entry level understanding of economics. Maybe you would find one or two creators, but not that many, right? Considering Marxist economics is supposed to be the scientific tool of the masses, of the average working Joe. So, yeah. So, the structure of the talk will be as follows. First, we are going to comb through Marx's arguments and see how he arrives at his conclusions. And after that, we are going to be going through Okishio's process by which he derives his conclusions. And then we are going to be looking at Deepankar Basu's edition, which tries to somehow reconcile the two. And then after that, for the end, we will be giving a short glance at Okishio's reply to the replies to his original theorem. So we will be looking at his 2001 paper to see how he corrects his theorem and how he draws new conclusions, which are very interesting and quite stunning in their own right. So without further ado, let's start with the Okishio theorem. So we'll start off by introducing this guy. This guy right here is Nobuo Okishio. He was born in 1927, living to see 76, I believe. He was a Japanese Marxist economist and professor at Kobe University. Other than that, he was also president of the Japanese Society for Economics and Econometrics. So, a very smart fellow. So what this guy did is he dedicated the better part of his academic work to studying Marx and Marx's theories, and providing some of the first formal proofs of his arguments. He basically crunched all the numbers and illustrated in very sturdy form how Marx's arguments operate. Some of his most important contributions to economic theory are the fundamental Marxian theorem, which we will not be discussing here but is of very great importance, and the Okishio theorem, for which he is the namesake and which is the topic of this video. The Okishio theorem is primarily concerned with questions of technical change. So these are questions concerned with the accumulation of machinery, the advancements of productivity, generally changes in technology, and how these in turn affect the rate of profit. Turns out Marx was studying these same dynamics some 100 years before Okishio, and by studying technical change and the rate of profit, he arrived at one of his most important conclusions, which is the law of the tendency of the rate of profit to fall. You will see it abbreviated as such. Basically, Marx is saying the rate of profit must fall with technical changes. You can see this illustrated here. And don't worry, all will be explained. So you can see as time goes on, K grows. Marx attributes this movement to technological change. And in the same time, the rate of profit follows this K, but in the opposite direction. It falls. However, Okishio, when examining these same questions, arrived at different conclusions. He says the rate of profit must grow. It must grow even as technical change progresses. So what he's doing is he's basically developing a law of the tendency of the rate of profit to grow here. So you can imagine this caused quite a stir in academic circles at the time. It raised a lot of dust in the admittedly dusty Marxist circles. So he's basically not just showing Marx isn't right, but that Marx is wrong, that he misses the ballpark entirely. So the theorem was very controversial and deserves a close examination. By examining how Marx and Okishio draw these different conclusions, even as they examine the same sort of dynamics in capitalism, we can probably derive some conclusions of our own. So this is what we're going to be doing in this video. For starters, we'll be looking at Marx here, and we'll be examining how he derives his law of the tendency of the rate of profit to fall. It's worth noting before we continue that Marx is using the labor theory of value. He was a big proponent of it and also one of its greatest contributors. Basically, what the labor theory of value does is it looks at, for instance, a vase. You look at a vase and it has flowers in it. And then you also look at a car. So a car. And these two things are completely different. The car is used for driving, for transporting goods, for transporting people, making distances shorter, while the vase is used for decoration, is used to store flowers in or whatever. So these two things are completely different. Yet, when you go to the store, they will both have a label on them. One will be, for instance, $1, while the other will be, say, $4,000. So what gives? What we are actually doing here with these labels is comparing the car to the vase. We are saying the vase is worth 1 unit of something, while the car is worth 4,000 units of this something, this dollar thing. But what actually is this dollar thing? It seems to be some kind of substance that is common to both, that we can compare. So what Marx does is he claims the market uses a sort of measuring stick by which these totally different commodities can be abstracted and compared. And this common essence is value, labor value. So we have 6 hours labor performed, which Marx says produces 6 hours labor worth of commodities. So 6 hours labor is 6 hours of value. This is the common attribute of both these goods. They both have value and they have different amounts of this value. So if you think about it, what is in fact going on here with the car and the vase is there is less labor in crafting the vase relative to the labor performed in assembling the car, which is what gives rise to these different prices on the labels. By studying the labor theory of value, Marx developed his value composition of capital. So basically, if you look at any single commodity, for instance, a video game console, the console will within itself have a certain amount of value. This bar is the total value. And a part of this value will be, for instance, the raw materials. So you can imagine that for the console, you have the lithium, the aluminium, the plastics. And this is all what Marx calls dead labor, this dark gray bar here. It is the indirect labor. It is labor embodied in the commodities, so in the plastics, the aluminium, the chips, and the wires, which were bought and to be used as inputs. It is the past labor already performed to create these commodities which are bought. And this is usually labeled C, as in constant capital, which is another name for it. Another input besides dead labor is, as implied, living labor. Living labor is the actual labor employed in the process working the dead labor inputs to produce the final commodity, which is the console. And this part is denoted with the symbol capital L. Furthermore, this living labor is composed of two separate parts. One is variable capital, V. You can think of this as wages. This is the part of the time spent working. The living labor is the full time spent working. So part of the time spent working that is given back to the workers as wages. Again, V, as in variable capital. The part of the time the workers spend working for the capitalist, so not for themselves, but for the owner of the final output, is called surplus value, the profit, usually marked S, as in surplus value or surplus labor. Now, there also exist relations between these different segments of capital. So we have constant capital, variable capital, and surplus value. This is living labor, and this is dead labor. The relationships are as follows, and prepare yourself as this will be a bit dense. There exists something called the organic composition of capital, marked by the symbol K. This organic composition of capital, K, is both the relationship between constant capital and variable capital, so C over V, and the relationship between constant capital and living labor, so C over L. In the former case, it's small k, and in the latter, big capital K. You can basically imagine an investor going in and spending a portion of his money on the machinery and a portion of his money on the wages, the total being his total investment. As the portion of machinery, of dead labor, to the portion of wages grows, so grow the Ks. So this organic composition of capital. Other than this, there also exists a relationship between the separate components within living labor itself. And this is called the rate of exploitation, noted by small e. This rate of exploitation is S over V. So, as part of the living labor changes, such that more and more of the day is spent working for the yellow bar, for the profits, for the capitalist, and then less of the time is spent working for wages, for the worker, meaning S grows and V shrinks. Which in turn means the rate of exploitation has grown. So basically we have these two relations within capital. The organic composition of capital, so C over V, the relationship between machinery and wages. And then we also have the relationship between wages and the profits, which is the rate of exploitation, S over V. Now, concerning the value composition of capital and its interrelations, we are going to go back to our black and orange bar. On this side we have constant capital, the dead labor, and on this side we have living labor, the orange bar. What Marx claims will happen as technical change advances is that with time, this black bar will basically consume this orange bar. So the black bar advances and the orange bar recedes. This change in the organic composition of capital with time, so the tendency for C to push on L and for L to retreat, is called the tendency of the organic composition of capital to grow. So the machinery part is replacing the labor. Less and less people are working to produce something, and more of the actual investment goes into the technology part. And with time, the final product will have the composition of capital as such. A smaller and smaller portion of living labor and a greater and greater portion of dead labor. This is the tendency of the organic composition of capital to grow. And it is quite central to Marx's argument of the tendency of the rate of profit to fall. So we'll have to keep a close eye on this movement. We should now recall that this orange part of the bar here is composed of variable capital and surplus value. So as constant capital advances, it squishes the variable and surplus parts. So as this happens, obviously the big K, so C over L, relation has changed. The big K has grown, and also the small k has grown, because V has shrunk. So C over V has also grown. In this case, exploitation, the relation between profits and wages, has not changed. Yes, they have both been squished, they have both receded. However, their relative sizes, the amount of V for amount of S, remain unchanged. They're still both equally large relative to each other. However, it is obvious that at the end of the day, the amount of yellow, the amount of total profits, has shrunk. But this begs the question, why would capitalists invest in technical change if technical change results in less profits? Why would anyone have it in their right mind to innovate, to improve on technology? There is an answer, and Marx's answer to this is superprofits. Basically, Marx is here claiming that there exists a reward, like a treat, for capitalists who innovate. This reward manifests as superprofits. To explain, we'll take a look at an example economy. So this is a typical capitalist. you can think of this as like 99% of all capitalists in this industry, in the potato industry. They use 8 hours of labor and some technology, say some wooden carriage mechanism, to produce 8 hours value of potato. In this case, 8 kilograms of potato. This is the majority of capitalists, the majority of the market. This is how it is usually done. And then you have also a few old-fashioned capitalists. They are underperforming capitalists. They make up like 0.5% of the market. They are the backwards capitalists that have not yet been driven out. What they do is they do not employ the new technology. They are using an old, a manual method of extracting the potato. So they are using, say, 16 hours of labor to produce the potato, the 8 kilos of potato. But their 16 hours of labor do not produce 16 hours of value in the potato. They are still producing the same amount of kilos, right? And what happens is that the market has a sort of regulating mechanism in which the typical mode of producing some output is the one that will dominate and exert pressure on prices. If you go to the market and you see two stalls next to each other selling the same exact good, but one price is at double the price, so you'll buy the cheaper one, right? You'd be insane not to if they're the same exact good. So as this is the typical method that 8 hours produce 8 kilos, then in the market, when the underperforming capitalist delivers his 8 kilos, it will also sell for the 8 hours value. In fact, he will have 8 hours of his labor performed not count. He's basically operating at a loss. Then we have another capitalist. Again, let's say a very small minority of capitalists. This is the innovative capitalist. This capitalist, instead of using the wheel carriage to extract the potato, he is using some more mechanical technique. He's using a tractor-based extraction method, for instance. With it, his 4 hours of labor produce again the 8 kilograms of potato, which are, due to the typical capitalist method, valued at 8 hours of value. So what actually happens here is that he is appropriating 4 hours of labor that he did not perform when selling the potato. And this 4 hours of labor unperformed, which count to him, is called superprofits. So this is superprofits. And this is basically the mechanism by which capitalism incentivizes innovative capitalists to invest in innovation, to boost productivity. So basically, with time, you can expect this innovative capitalist will drive out the typical capitalist, which is driving out the underperforming capitalist. And now we've come to the rate of profit itself. We have all the tools necessary to analyze it and to see how the relations inherent in the rate of profit result in its very downfall. So we'll go back to this familiar bar. So constant capital, variable capital, and surplus value. Now imagine yourself in the shoes of a capitalist. You have some amount of money, some amount of money labor that you wish to invest in a production process. When you are investing, you are looking at the investment cost. You are investing in the machinery and you are investing in the labor that you have to employ to work it. After you have invested this and have sold your product, you get back a profit from the unpaid surplus labor. And then you will basically look at the relative relation between this profit and your investment. This is the rate of profit, the relationship between profit gotten out of some production process and the investment into that production process necessary. Imagine that this specific composition of capital is that of a typical capitalist producing some good in some industry. However, in that industry, there may also exist an innovative capitalist. How will their composition of capital look like? Well, like this. So the portion of the living labor is the same in this example, right? But the surplus part will consume part of the wage labor. This actually corresponds to a part of the wage workers being fired. So this part is being fired. And this is then appropriated as superprofits. This difference between the average capitalist and the innovative capitalist manifests as superprofits. And so what happens with this capitalist, the innovative one? Well, they're obviously getting the super profits, and they're getting their treats for innovation. And they will be investing those profits and expanding much faster than the other capitalists. They will basically be outcompeting them, forcing them to either go bankrupt or to innovate themselves and become this innovative capitalist. In effect, with time, the innovative capitalist becomes the typical capitalist. Now, recall that there is a sort of mechanism by which prices on a market are determined. This mechanism is such that a typical capitalist, the one controlling most of the production, will be the one determining the actual values and prices of the outputs. So what is of concern to us is what happens to the super profits in this process of this innovative capitalist becoming the typical one. And what happens to the super profits is that with time, they evaporate, they fizzle out, go down to nil. Notice the rate of exploitation, the relation of wages to profits, is the same as before the innovative capitalist showed up. So what the capitalist class is left with is a new organic composition of capital, a new composition of capital in general, which is different than the old one. To draw the old one to compare, of course, we can see this entire bar is less, it is smaller, and this represents less time being used to produce the same amount of commodities. So this is less than 1 hour to produce 1 kilo, whereas this is 1 hour to produce 1 kilo. So this is 1 kilo of potato, this is also 1 kilo of potato. But we are not interested in the units. We are interested in the actual value composition of the potato commodity. Imagine now our capitalist, and they have some amount of value they wish to invest, like $100, or what amounts to the same thing, 1 hour of value. And then they would look to compare these two developments, these two situations. We will, of course, have to expand this, so they both now represent 1 hour of value invested. Of course, this represents more than 1 kilo now, and this represents only 1 kilo, but for the capitalists, this is absolutely of no concern. What they are concerned with is if they give 1 hour of value invested, what they will get in return. What they would do is recall the good old days, where 1 hour of his value would bring about this rate of profit. The capitalist will realize then that the new status quo, the new order, is such that the surplus value to investment ratio is less. It has subsided with time. More actual things are being produced in less time, but each of these units has less value in it. So if we look at this profit bar relative to the investment part of the bar, it will be a greater ratio than this smaller profit bar relative to this much bigger investment bar. So in effect, the rate of profit has shrunk. Old R is larger than this new R, than the new rate of profit, marked by this apostrophe. And voila, this is the tendency of the rate of profit to fall, as first formulated by Marx some 150 years ago. With time, as technology advances, as innovative capitalists innovate in order to gain super profits, the organic composition of capital will inflate, the super profits will dwindle, and the new situation, the new status quo, will be such that the rate of profit has declined. This is the tendency as such. Now that we understand how the original argument formed by Marx works, it is time to examine what is in reality an attempt to correct this argument. It is time we examine the Okishio Theorem itself. For this, we need a very short acquaintance with this absolute legend here, Vasily Vasilyevich Leontief, born in 1905, living to 1999. First a Russian born in Germany, and then a dissident in Soviet academic circles of Leningrad, then a prodigy in Germany, and after that followed Harvard University and an impressive career in the US state sector, where he worked on using computers for mathematical and statistical modeling. In this last phase, he made one of his greatest contributions to economics, known as the input-output analysis. And for this, he also received the Nobel Prize in 1973. This input-output analysis was also kind of inspired by Marx's two-department reproduction schemas. And the reason we're talking about Leontief here is because this input-output analysis he created has since been used in formal treatment of economic theory throughout. And it is especially of importance for Marxist economics. The input-output matrix has become the primary method by which Marxist economists conceptualize and define models when formulating proofs and theorems. For this reason, I think it will be worth it getting acquainted with just a few more letters and symbols. Of course, this input-output analysis is also a tool Okishio used when formulating his theorem. However, in this series, we'll be using a very simplified version of this. The full model uses matrices with arbitrary many commodities and industries, and this can be kind of overwhelming. So we'll be using a model economy with only one single non-labor commodity. By simplifying, we will not in reality be reaching different conclusions, but we will be avoiding a lot of hassle. Also, where this simplification will differ from the full model, it will be pointed out. So, for starters, this will be a single output economy. The economy has only one output, for instance, grain. This grain also flows back as an input to itself. You can think of it as part of the seeds going back into planting the grain. However, it is not the only input. After all, someone has to plant the seeds, and the crops definitely won't harvest themselves. So the other input is labor. So we have labor marked with letter N and grain marked A, coming together in the production process to produce grain. Of course, you don't go and clock in at work without getting something in return. It is reasonable to expect that this labor input is paid some sort of wage. For this, we have to imagine that every worker gets a sort of bundle of physical goods, a consumer goods basket. This bundle is marked with the letter B. In this model, it sadly has to be some amount of grain in a plate, which is also made of grain, I suppose. So we have the grain wage bundle multiplied by the number of labor employed, by the number of people employed in labor. By this, we reach the total wage expense, which is here 3 bundles. It is also worth noting that this wage bundle, the physical amount of grain in the bundle, is fixed in this model. So we are following a kind of Lassallean iron law of wages. The idea is that there exists a class conflict that will generally drive down wages to some defined minimum, right? Now, as the whole profit rate and organic composition thing is about changing technology, it is time we analyze what the conditions are for capitalists to decide to adopt a new technique of production. There are 3 criteria: productivity, progressiveness, and capitalist viability. And we will now go over each in some more detail. For a technique to be productive, this means it has to produce more than it consumes. There has to be a surplus product. Here we see that we have an input of N labor and A raw materials. This together produces N plus A grain. Some of this grain goes into the raw materials flow here, so basically all of the A grain goes back to itself. Some of this grain goes back to the workers as wages in this wage flow here. But some, and this is the productivity condition, must be left over right here. So this is the total product minus the raw materials and wages. For this leftover to be positive, for the technique to be productive, this total product then has to be larger than the expense flows. For a technique to be progressive, this means less labor time has to be spent to produce the same output. Basically, more and more output has to be produced per hour work. Suppose you have these 2 workers working this raw input to produce an output. You can imagine this raw input, just like this output, has inside it also some labor from the period prior. So all this labor produces this unit of output. Now, after the new technique has been adopted, we see we have less labor being used to produce the same amount of output. This lambda symbol represents labor time. It represents value. So the labor time value of the raw input plus the direct new labor time. So the total labor time content of this new technique has to be less than the labor time content of the current technique. Now, finally, and most importantly, for a technique to be capitalistically viable, there has to be cost cutting. So the new technique costs have to be cheaper at current prices than the current technique that is being replaced. So prices are defined as N, or all newly performed labor, over the output of this newly performed labor. So since we're using a simplified single commodity model, there is no transformation problem, which means prices are equal to values. And this P just equals 1. So let's say this here is the typical capitalist technique at some point in time. This much labor in money terms and this much raw materials in money terms produce this much output in money terms. Now, let's say winds of change are sweeping the industry. The typical capitalist is becoming old-fashioned. So let's give them a top hat and a monocle. Now, the innovative capitalist enters the scene. At same prices, they use less labor and raw materials. This means the total cost is less than that of the typical capitalist. Of course, in competition, the typical capitalist will lose out on profit as both gain the same profit, but one has cut costs. So the capitalist viability condition is basically the old price of new wage cost plus old price of new raw inputs has to be less than the old price of old wage costs plus old price of old raw inputs. Or this would be the capitalist viability condition where we're using a multi-sector model. Since we are definitely not doing this, prices are equal to values. So the P's are just equal to 1, hence we can ignore them. Therefore, the capitalist viability condition is as such. The new costs in wages and raw materials have to be less than the old costs in wages and raw materials. Simple as. So here we have the 3 criteria that have to be met for a new technique to be adopted, according to Okishio. The new technique has to be productive, it has to be progressive, and capitalistically viable. I'd say these assumptions are quite reasonable. And now the time has come, finally, to see the Okishio theorem in action. And so the familiar bar returns. This is the raw materials, this part is the wages, and this is the surplus. For simplicity, let's group the expenses as the blue bar. Suppose this is using the typical NA technology. So N amount of labor and A amount of raw materials. To calculate the rate of profit in this model, we just take the profit price and divide it by the expense price. Since the prices equal values, we can ignore them. And then for clarity's sake, we'll take out this part here like so. And so this is the rate of profit for this technology. Now say an innovative capitalist walks in and does his innovating. Let's give him his own bar here. How would his rate of profit look like? Well, recall the capitalist viability condition. It's this here. So the expense part has to retreat and give way to the profits part. And the rate of profit of the innovative capitalist, R mark, is as follows. And again, since prices equal values, we can ignore them, and by taking out this part here, we get this rate of profit. Obviously, as A mark plus BN mark is less than A plus BN, the innovative capitalist's rate of profit, R mark, will be greater than regular R. 1 is being divided by a smaller number, meaning this number grows, right? Okay, so same old story. By cost cutting, the capitalist has gained super profits. But what happens when new prices form? Well, we have the new general rate of profit, R double mark. This is the rate of profit when the innovative capitalist and the typical capitalist have become one. It is the profits using the new technology judged at new prices divided by expenses using new technology at new prices. Since prices are again equal to values, you can see this is still equal to 1. We ignore them. Then we clear it up and we get the same formula we had for the innovative capitalist, meaning R double mark equals to R mark. Now, this is despite the fact that the organic composition has grown. In fact, it can grow quite a lot. It does not matter as long as the capitalist viability condition is met. In effect, the new general rate of profit, R double mark, is equal to the innovative capitalist's rate of profit, R mark. And they are both greater than the old general rate of profit, R. It is worth noting that the new general rate of profit is equal to that of the innovative capitalist due to us using a single sector model. In a multi-sector model, R double mark does not equal R mark. Super profits do dwindle actually. However, it can nonetheless be shown that R double mark is greater than regular R. Thus, the theorem holds. And the new general rate of profit will always be greater than the old general rate of profit following innovation, even if the organic composition of capital grows. And if you follow this math, this is inevitable. So we've arrived at a conundrum. Marx and Okishio are at loggerheads. It is immediately clear why the theorem was so controversial. So it is now time to carefully analyze what actually happened here and why the conclusions differ to such an extent. It can be argued it actually all comes down to something surprisingly simple. Let's look at an example, starting with a Marx-styled schematic. So we have this technology for a start. If we use relative outputs as a measurement of time, the rate of profit would be this. So that's 38%. Small k would be this. So 160%. And the rate of exploitation would be 100%. Now, suppose a new technique is implemented. Super profits dwindle, and this is the new typical production technique. You can see more output is being made per hour. The rate of profit is 33%. Small k is here 200%, and the rate of exploitation is again 100%. It's constant. Fair enough. We have the organic composition growing and the rate of profit falling. Typical Marx. Now to take a look at Okishio. Starting from the same technology, so the rate of profit, small k, and rate of exploitation are here identical to Marx's starting point. Now, as the new technology is implemented, the following happens. The rate of profit is now 60%, so definitely a jump. Small k has also grown with the profit rate and is now a stunning 400%. And what is key, the rate of exploitation has increased to 300%. So in essence, Okishio deviated from Marx in one crucial way. Okishio has a fixed wage bundle in units. This means as innovation makes goods cheaper, both the wage bundle and the raw materials here become, cheaper. This means the worker has to spend less of the working day working for his wages. This means the capitalists gobble up all the gains made from innovation. The exploitation rate is variable, so the rate of profit must grow. With Marx, the story is much different. With Marx, the wages are variable. His assumption is that workers will struggle for better working conditions and share in the benefits of innovation. They will do this to such an extent that, with Marx's example, the rate of exploitation is fixed, so the rate of profit cannot but fall. So we're left in a bit of an uncomfortable position. Sure, Marx and Okishio differ in assumptions, that's all fine and dandy. But this begs the question, which of the two assumptions should we use when making our observations about the real world? Which assumptions are the most useful in doing this? Who is right, Marx or Okishio? Well, really the answer is neither or both. It depends really. Suppose there exists an economy with this many available workplaces. And suppose this many are filled with employed workers. And then let us say there also exists a labor market, and it is filled to the brim with the unemployed masses. In this situation, what would you suppose the bargaining power of the working class would be compared to that of the employing class? Well, it wouldn't be good. It would be really bad, actually. And the reality is the boss could just walk in and demand you work unpaid overtime. And you couldn't really do anything about this because it is very likely that there is someone much hungrier than you on the market who will be willing to do this extra work. So, if the working class is weak due to unemployment or due to otherwise not being organized into a fighting labor movement, it is likely that wages would plummet to some minimum where they would stay as long as the situation remained unchanged in this regard. We would then observe Okishio to be right. Now, suppose the economy has expanded a lot. There was a boom in expansion. And now most of these workers are employed elsewhere. Along with them, the labor market has been completely drained. Instead of the unemployed, we just have this fly buzzing about. The capitalists will now play a different tune. Instead of demanding overtime, the capitalists will be forced to pay paid vacation, breaks, paid meals, and so on. So the power of the working class is here much greater. So if labor is in high demand or is otherwise organized in a powerful labor movement, it is likely that the working class would share in the benefits of innovation in productivity. In this case, we would observe Marx to be right. Deepankar Basu, an important contemporary Marxist economist, claims that mathematically speaking, an Okishio-styled model can be easily adapted to account for this working class power. This is done by adding another variable, alpha, to the BN, wage complex. What this variable does is it basically scales the base wage. So if alpha is 1, the wage is the same as it would be if alpha did not exist. However, if alpha increases by 1/3, then we see the amount of goods has also increased by 1/3. Likewise, if the alpha decreases by 1/3, then the real wage in goods has also diminished by 1/3. As we recall, Marx claims the rate of profit falls with technical change, while Okishio claims it grows. Basu also observes that there exists a specific value for alpha at which neither are right. There exists a threshold of sorts at which the rate of profit has remained unchanged despite technology changing. This threshold is denoted as alpha star. If alpha, so the wage change, grows less than alpha star, then Okishio is right, and the rate of profit will grow with technical change. If, on the other hand, alpha becomes a number greater than alpha star after technical change, then Marx is right, and the rate of profit will fall. Let's take a look at an example to let this sink in. Suppose we have two workers working 3 raw inputs to produce 9 outputs. So the technology is 2, 3, and the output is 9. Now let's set the wage bundle at 2. So each of these workers gets 2 units as wages each. Let's bring up the flowchart and see where this takes us. So out of the output, these 4 units go to wages as BN. These 3 units go back as reinvestment raw inputs for the next cycle. And this, what is left over, is the profit, which belongs to the capitalist. So let's now calculate the rate of exploitation. That's 50%. And the rate of profit, 28.5%. Okay. So now let's see what happens with technical change. Going back to our starting schematic, and this time only one worker is needed to produce the same output using the same raw materials. So the technology is 1, 3, and the output is still 9. The wage bundle will be 2 again, so it's fixed. So the worker gets his 2 units. 3 are taken out for the next production cycle, and the capitalist is now left with 4 instead of 2 units as surplus. So the rate of exploitation is now 200% instead of 50%. Now for the profit rate, it has grown to 80% instead of the 28.5% we had before. Since the rate of profit has grown, this alpha here has to be less than the threshold alpha star. This is Okishio style technical change. Now let's go back a bit. So again, the technology has changed, and again it's 1 worker for 3 raw inputs, producing an output of 9. The wage bundle is still 2. However, this time the working class is powerful and has demanded a greater wage share than before the innovation. In fact, double the wages are demanded. And now the rate of exploitation is back to 50% instead of 200%. And the profit rate, it has gone back to 28.5% instead of growing to 80%. In fact, we can see that after this technical change, the basic relations seem to be exactly the same as if there was no technical change at all. So alpha must be equal to alpha star. This is exactly on the threshold. If the workers demanded even more for wages, then we would have alpha greater than alpha star, and Marx-style technical change would occur. Now, I think we can all agree that it is reasonable to say that we should expect our models, theorems and observations to have some basis in reality, in the real world. All of this bickering about the tendencies of the profit rate would be pretty senseless if we can't in some way apply what we learned. What we can do now is look at some data and see how this all fits in. This here is a graph that depicts the movement of real wages, of productivity, and the profit rate in the United States spanning the period of circa 1939 to around 2009. The data in this graph is taken from Anwar Shaikh's book Capitalism, Competition, Conflict, Crisis, released in 2016. You can find the visuals on pages 60 and 66, combined here in one graph. First off, we should focus our attention to the productivity curve, the black dashed line. We can see it following some uninterrupted linear growth. By the way, this productivity curve and the real wage rate are just indexes, with 100 being 1889 outside the graph. The percentages are for the profit rate, and anyways, the productivity curve is clearly linear. Following this linear curve very, very closely is the real wage, the dotted red line. So generally speaking, as productivity increases, so as technical change advances, so do real wages. And then somewhere around this point, around this blue dashed line, something happens. Some strange force is released that completely changes this relationship. The real wage curve detaches itself from the productivity curve. This decoupling event is in reality the neoliberal revolution. So we should note both Reagan and Thatcher were elected into office around this time. Also around this time was the end of the Bretton Woods system, so money became in effect completely detached from gold. And now if we look at the rate of profit, the solid yellow curve, we see that something happens to it that coincides with this decoupling event, with the neoliberal revolution. We can see the rate of profit in free fall from around the 1940s up until shortly after this event. After the real wage stagnates, the rate of profit stops falling and itself begins to somehow stagnate. But the neoliberal revolution was clearly successful. Even though the rate of profit is not rising, at least it was saved from freefall and brought to a plateau. Drawing a parallel with what we have learned so far, it is clear that before the decoupling, we have workers enjoying the benefits of increased productivity. This means that their real wage bundle is growing as productivity grows. If we recall Basu's threshold, this in effect means that the alpha is likely greater than alpha star. And the rate of profit, of course, falls. This is just as Marx predicted. However, after this decoupling, we have the real wage bundle basically fixed and static, despite productivity continuing to increase. We read this as the alpha being approximately equal to or greater than alpha star. So the rate of profit stagnates. This is, well, it isn't Okishio exactly. The profit rate is not growing. So let's just put a big fat asterisk here. However, this is definitely not Marx's tendency as he formulated it. Something very specific and strange is going on. So we can here clearly see that this assumption of fixed or variable wage is conditional on the historical time period, on some other so far undefined events. Basu's alpha variable takes these into account. However, this is done in a sort of ad hoc manner. The issue is basically, while the Basu threshold can tell us when the wages are changing such that the profit rate behaves in a certain way, it cannot really tell us why the wages are changing as such, why the working class is becoming more or less powerful. Well, I don't think a good approximation exists thus far, so I haven't seen a decent formula for this, and I doubt it exists. There has been an attempt at sort of climbing this mountain. And this attempt was made by none other than Okishio himself. In fact, he made this substitute in response to all the drama around his theorem as a correction. So before concluding this video, we'll give Okishio a chance to defend himself. So we'll take a short peek at his 2001 paper, Competition and Production Prices, published in the Cambridge Journal of Economics. So this here is the paper. And this page here is public. For the rest of the paper, I'll be blurring the majority of the content to satisfy fair use. So if you're concerned your vision might be failing you, this is not the case. It's just a filter. I will now read a part of this page. Quote, many people have criticized the Okishio theorem. These criticisms have not persuaded me because given the assumptions, the theorem is valid. However, I now think my assumptions were inappropriate. The Okishio theorem asserts that if the real wage in terms of consumption goods is constant, and a new technique which lowers unit costs in terms of the present price wage production price configuration is introduced into a basic sector, then the equal rates of profit must be higher when the new equilibrium is established. Although the original theorem is logically valid, it rests on two questionable assumptions. First, that the real wage rate is constant, and second, that the new production prices are established. End quote. So the first assumption is familiar, and as for the second one, it has to do with using matrices, so a multi-sector economy with unequal compositions of capital. This second assumption is less relevant and does not concern us since we are using a single sector model with one profit rate and one organic composition of capital. Then Okishio goes on to explain the assumptions in more detail. Quote, the assumption of a constant real wage rate implies either a non-monetary economy or the instantaneous adaptation of the money wage rate to the prices of consumption goods. Both are unrealistic. End quote. So by non-monetary economy here, he's talking about either an abstract pre-capitalist economy or some sort of moment in capitalism where wages do not act naturally. They are fixed. For example, maybe there is a serious war on, and due to a shortage in goods, the state is rationing everything under the sun. By the instantaneous adaptation of the money wage rate to prices, he means to point out the fact that prices of goods are, with technical change and time, shrinking, and wages automatically and instantly follow this change. It's as if your boss is cutting your wage day to day in tandem with price changes. Continuing, quote, a capitalist economy is a monetary production economy. Laborers receive a money wage. The money wage rate and the prices of consumption goods change owing to competition in the consumption goods market and in the labor market. The assumption of a constant real wage rate cannot be maintained. End quote. So he's lifting the assumption of a constant real wage, the hallmark of his theorem. And in its place, he's placing this dynamic between the labor market and production. Let us now observe the effects. A lot of maths later, here we have our first of two concluding graphs. This one is without population or technical change. We can see the rate of profit plummeting with time towards zero. But again, this is without technical change disposing labor. So what's happening here is that the economy is still growing. Profits are still being used to reinvest and grow the economy. With this, new workplaces are opening up. As this happens, the unemployed population is being drained constantly. And as the labor supply drains, the workers gain bargaining power. The capitalists start competing with each other to get workers to work for them instead of the competition. And wages, as a result of this, squeeze the surplus. In this model, this process plays out until the capitalists are left with no surplus to speak of. But it's unfair to say there is no population change. Okishio mentions population growth is an exogenous factor. And in part he is right, as we'll see later, but only in 100 years. So going to the second graph, we see what happens if population growth is implemented. Here set at 0.01. We see the rate of profit falling again, but then it levels off at a value higher than 0. And as you guessed it, that value is 0.01, again 1%. The rate of profit now has a tendency to fall to the rate of population growth. But again, technical change is missing. However, if you think about it, implementing technical change has the same exact effect as population growth. So it displaces workers and sends them back into the reserve army, the unemployed, thus boosting the population. So in effect, no population growth and a constant rate of productivity advancement of 0.01 would, as far as the rates of profit are concerned, produce this same exact graph. So the Okishio theorem lies sort of disowned by its creator, and this new theorem states the rate of profit will either grow or it will shrink, depending on the composite of the rates of population growth and technical change. So let that sink in. The rate of profit, the rate at which capitalists enjoy a profit, will follow population growth and innovation in productivity. There is no going around this. This is huge. To see why, let's once again observe reality. For you here, I have a few graphs from the United Nations Department of Economic and Social Affairs. These here are the predictions for population change for this century. So take this in. The human population will stagnate around 2080. So following circa 2080, the only contributor to the rate of profit can be technical change. But now see what happens sometime after 2080. The population is shrinking. So it's not stagnating, it's falling. There's less and less people in the labor supply. The human population is not reproducing itself anymore. It will have a negative effect on the rate of profit. Keep in mind, this is the whole population for the whole world. If we limit ourselves to the majority of the working population, so we look at ages 20 to 64, this same process happens even earlier. And let's not forget, this is the whole world we're speaking of. If we only look at the so-called developed world, at the West, this process has already played out. The working population has just now started falling, probably for the first time in history, barring the world wars. Can the rate of technical change really catch up? It definitely has its work cut out for it, that's for sure. I don't know about you, but these are some stunning conclusions we can now arrive at. Of course, Okishio's new model is a very rough substitute, a rough approximation of the organization of the working class in its labor movement. The system may come to loggerheads sooner or later than predicted, depending on the ability of the capitalist class to assault and further immiserate us. And it also depends on our ability to organize and actually transform this crisis into a force for good, a force to tear down this twisted logic we've spent around an hour now talking about. With these interesting observations noted, it is finally time to conclude our not so little talk. So in conclusion, neither Marx nor Okishio were using appropriate assumptions for observing reality of capitalist development thus far. But what Okishio's theorem did is, despite the theorem itself being sort of faulty, is it brought to the fore an important question about the assumptions at play in Marxist theory. It exposed an important question, and I'm sure, or at least I hope, we can all agree that no good work can be done on solving a problem unless we first come to be aware of it. And this is the true value of Okishio's theorem. What the 2001 paper and Basu's edition have shown us is that Marxist economics has only been for the better due to this controversy the theorem caused. Marxist economics has been given a lesson, and it is a lesson I hope you've enjoyed sort of acquiring with me. It's been a long and very dense lesson, sure, but I hope that nonetheless it was an interesting and useful one. If you are interested in more stuff like this, I really suggest watching Text Talks series on Das Kapital. It's here on YouTube, but to get the series to appear in the search results, you have to type in Text Talks Marx in the search bar. Or you can just check out the description below this video where I'll link to the series in question. Also in the description will be the sources, all of which are great reads in their own right. So this concludes our talk about the Okishio theorem. Who knows, maybe it will be of use to somebody out there. Suffice to say, my artistic ghosts and insistence on posterity have both been satisfied. Anyways, thanks for watching and have a good one.